Okay, I think we are good to go. So again, welcome everyone. Thank you for joining us for the RITIS user group meeting. My name is Nicole Forrest, and I'm with the Eastern Transportation Coalition as the TSM&O Program Associate. Um, Today we're using the Zoom webinar, and we are recording this meeting for uses internally, and then we will have the audio. If you're using your computer and phone, you can use as an alternate. And then any questions that you might have with the audio or the web or challenges with that, please contact me directly. There's my email up on the screen. And you can use the Q&A box for questions to the presenters. We do not um, need to use the chat box. So just reach out to me if you have any issues on that. Okay. Next is, here's the Q&A box. It's at the bottom of your screen. And next slide. And then if you have a question, please raise your hand. And then we can ask you to unmute to ask any questions that you may have. Coming up, we have our next RITIS user group meeting that's scheduled for September 4th at 1:30 p.m. So invitations will go out for registrations once it gets closer to the meeting. So with that, I would like to turn it over to Matt Glasser, who's our co-chair. And you can take it away, Matt.
Wonderful. Thank you so much, Nicole. And I think we can go ahead and hop on into the next slide. So again, welcome to our meeting today. Really excited to have you. We have 100 folks that have already signed in, with participants scheduled to be from over 33 states today. Again, I feel like every time that we're doing this, there is another group, another team, another state that is joining us. So we're very excited to see that ever-growing group every single quarter. So for today, obviously you've heard Nicole give us a great introduction, and hearing me do some intros right now. But as we get into this, we'll have Bob Fry, the first Bob Fry today, from THEA. He's the Director of Planning and Innovation, and Charles Latimer doing their agency spotlight. Greg Jordan will be up next to talk about our truck parking analytics capabilities and what's coming up with that. Michael Pack from the CAT Lab will run us through some general updates about what our new features are, and I'm sure Michael Pack or Bob Fry from MassDOT will be happy to chime in with that as well. And then at the tail end, we'll have plenty of time for feedback, questions that this group may have, and some additional survey questions at the very tail end. So with that, let me go to the next slide and introduce our speakers for today. Michael Pack is the director of the CAT Lab at the University of Maryland, where he works to make transportation data more easily accessible and usable by ops, planners, and researchers. He has previously worked for the University of Virginia and the Oak Ridge National Laboratory. Charles Latimer works for the University of Maryland CAT Lab as well, where he helps transportation agencies improve communication through better data visualization. His roles at the CAT Lab involve promoting user-friendly enhancements to the RITIS suite of performance tools and guiding the development of the RITIS signal analytics platform. Between his time spent with the university and the private sector, he has over 22 years of experience in transportation data and intelligent transportation systems. Greg Jordan is the feature manager for the CAT Lab's trip analytics toolset. Prior to joining the CAT Lab, Greg managed a helicopter survey company that conducted 80 origin, destination, and routing surveys using aerial video to trace vehicles. He's also used the helicopter results to validate the use of INRIX trip path data sets for origin destination surveys. Greg has drawn from these experiences to design new capabilities and features within the trip analytics tools. Bob Fry from THEA serves as the planning director for the Tampa-Hillsborough Expressway Authority, as I just said, that's THEA, and is the project manager for THEA's connected vehicle pilot deployment. Bob has more than 30 years of experience working with local and state agencies, as well as toll agencies. Since joining THEA in September 2012, THEA has embarked on several new initiatives with a focus on improving mobility in the Tampa Bay area, including the development of the Selman Greenway and the award of the US DOT CV pilot deployment. As part of the US CV pilot deployment, Bob has experience with both the technical and policy changes of deploying emerging technologies. He holds a master's of public policy from Baylor University and is a member of the American Institute of Certified Planners. So with that, did we have a poll that we were going to do, Nicole, or are we just going to go ahead and bypass that and hop right in to our first speaker?
Yep, hop right into our first speaker.
Excellent. Well, with that, let's do it. I believe, Greg Jordan, you are the, or rather, Bob Fry, you are our first speaker. So I will hand it to you, and I'll be happy to hang on and make sure that your audio and screen is sharing appropriately.
Greg Jordan, you're up.
Sorry, it's Bob Fry. That was my apologies.
Okay.
I actually have I have a short first part that I'm doing, and then I'm doing my major presentation a little bit. So Michael, you want me to just go ahead with the MAP 21 update?
Yeah, real quick update, and then we'll get into Bob's stuff. Sorry, Bob.
Yeah, don't worry about it.
Okay.
Apologies.
Okay, and I've got 4 slides. Are we on my first slide? Because I haven't pulled it up yet.
Yes, we are.
Okay, good. This is about a quick update on PM3. This is the program sponsored by Federal Highways. It's part of HPMS. Next slide, please. The idea is to use the regulation, the reauthorization regulations, starting back in 2012, created the need for states to measure one method throughout the entire state on the national highway system and provide measures of basically congestion and reliability. And there's required submissions every year for the previous year. Next slide, please. RITIS has a suite of tools to assist states with this compliance and reporting, but also with analysis using the metrics. The idea is to help spur the states and agencies and their partners to use the new modern probe speed data. Adoption across the country has been different at different agencies, and this program has really fostered the development of it. These tools allow you to prepare the reports that are due. Next slide, please. There's a 4-year term where each state agency and various MPOs will set targets for the next 4 years. At the end of the 4 years, we evaluate whether or not those targets were met, and it's designed to give planners and programmers a better seat at the table when it's deciding funding for projects. We are now about to submit the reports for year 3 of the current 4-year term. Support at RITIS.org has been talking to all of the agencies that are using these tools, which are about 40 out of the 52. There shouldn't be anything anyone on this call needs to do, because as far as I know, it's wrapped up. All issues have been handled. And if you have any questions, you send an email to our support team and they can brief you about your state. This is only for states to submit. Any kind of MPO or other agency that's affected, their roads are included in the state submission, and that's why there's only one submission each year. So you're welcome to contact me, but really go through support if you have any questions, and we'll be happy to help you out. That's all I've got.
Very good. So with that, I think we'll go ahead, hop in to the presentation from THEA. And Bob Fry, when you are ready, feel free to do a mic check, and I'll verify that you're working okay.
Okay, I think I was working earlier, so we should be okay.
Yeah, sounds great.
Okay.
Screen's coming up, so you're all good to go.
All righty. And we may move through a couple of these slides very quickly on this as we go through. But so my name is Bob Fry. I'm the Director of Planning and Innovation at the Tampa Hillsborough Expressway Authority. And in my my biography, I put in a couple of different things on purpose, namely the Selman Greenway and the connected vehicle pilot for a reason. What we've been exploring connected technologies for quite a while, and one of the things that I wanted to, what I was really excited about this particular project and working with the Cat Lab is when we came out of the connected vehicle pilot. One of my personal view was we're relying heavily on the OEMs to provide data and to provide the safety messages and the things we're doing. How can we as a transportation agency make use of the investment that we have with RSUs and the different technologies out there without having to depend on, auto manufacturers, seeding that? And data and analysis is one of the things that came up with us. And our executive director, Greg Slater, who used to be over at Maryland, at Massachusetts Maryland DOT, he was big on data. So how do we use that? And he introduced me to Michael and the RITIS and the Cat Lab. And we've taken this and we're looking at how do we create a smart roadway with all the connected technology and all the information that we have. A roadway that actually tells us how to manage it and how and when it needs improvements and different types of route changes and things like as a toll road, our customer base. How do we give them the premium trip they're paying for to make sure we're doing that? And we contacted Charles and came up with a really good set of parameters that we're using with RITIS that we're now also using with our connected RSUs that we have out there on some of our more focused data to do that, and showing that it is worth setting up this connected technology and using it, and that we're using it for other means besides just what we saw in the CV pilot. And with, we're also seeing it with using it with pedestrians, and we're bringing in information from camera analytics on near miss analysis and other types of data for pedestrians and crossing to create this data hub. And this RITIS piece has been very helpful for us, and it's really been a great fit. So let's start with the first slide, and we'll go through and talk a little bit about it. As you know, we're a independent toll authority in Tampa, Florida, which means we operate under a board. We are not part of a DOT or a city where we are 100% independent. We do not take any tax money whatsoever. 100% user fee based. So for us, providing the trips that we tell the public and that our road being the choice that they want to take is very important. We run about as close to business as you can get. We have 4 different properties that, systems that we own. And now with both 2 arterials, Meridian Avenue, Brandon Parkway, and then the Selman Greenway, which is also a 3-mile trail through the middle of Tampa that was built as a mobility trail, not necessarily as a recreational trail. So the mobility piece on these crossings is very important to us. So next slide, please. Leroy Selman Expressway basically goes from Brandon, which is about 15 miles to the east, into downtown, and now all the way to Gandy Boulevard, which is we are the only limited access that goes in this area. Really, the only toll road for the east-west routes. East-west routes in Tampa are very that's a problem. North-south's not a problem, but if you look at the map here with the bay, east-west is, and that's definitely where we're at. 14 center lines. We run about 100,000 a day, depending on the location. And now working with DOT, where you can go from Brandon to the beaches with only hitting one stoplight. So that's one of the things we're proud of. Next stop. Innovation has always been part of Thea's. When you're a small 23-person agency, you need to be innovative to stay relevant. To be honest with you, we have a elevated reversible lane that runs from downtown Tampa to Brandon. We also were the first to go all electronic tolling in the state of Florida, and several other with the CV pilot and other innovative things. So we're always pushing the edge on what can we find, how do we make it better, how do we make the trips work, how do we make, as my executive director continually says, people are paying in tolls for a premium trip. If they are not sitting in traffic, is not a premium trip. So how do we continue to give it to them? And this is one of the things that we're hoping that RITIS and the smart roadway is that next step in innovation for us. And just for the record, we've had Taiwan, Israel, France, many different nations out here looking at our reversibles and how to use that for an urban environment and stuff. So we have some experience on the innovation side. Next slide, please. My goal is I want to take the RITIS and the mobility platform they have is such a unique tool and meld it with the data I'm able to generate and put out there. We've got 44 roadside units out that are picking up Bluetooth and picking up Bluetooth data and web data. I'm sorry, I've lost the word there. But how do we take that? We're using now camera analytics. We're big, on that on our pedestrian crossings and at our ramp terminals, using cameras to look at where we're going and looking at near miss analysis. My big saying anyway is, are we really safe or are we lucky when it comes to crash and safety? And using this data and using the camera analytics is helping us get an idea of where those areas are that we've had near misses and no real crashes, but we need to get in front of it. And that's part of what we're trying to do with all this data and analysis to show value, is to get in front of the curve rather than reacting to 5-year crash data that we would typically get. And as you can see, the different sources. Weather is an interesting one here because we had Audi out in 2014. Governor Scott actually rode in an autonomous vehicle on this Selman Expressway. And we thought that they were down here because the weather was good for testing all the time. When I talked to the engineers, I found out just the opposite. They're down here because we have such weather extremes. You go from 98 degrees to deluge and back in the same day. And the swings that they saw in June, July timeframe between the rain, the temperatures, and the extremity of the sun was one of the reasons they were looking at it. So weather for us is a huge issue. Tampa Bay is the lightning capital of the world. The Tampa Bay Lightning are named that for a reason. For example, when we had the CV pilot during one storm, we lost 17 of our 44 RSUs from a lightning hit. The lightning here is a major issue. So between the weather data and all this information with the Cat Lab and RITIS being able to provide it to us has been really helpful. Next slide, please. What we're looking at is how are we using the probe and the trip data. Charles Latimer has been helping us with this. One of the things that I've liked about work, Charles, if you'd like to talk about this screen a little bit, or I'd appreciate that.
Yeah, sure. I can kind of pick up from here. So Bob gave us a really great opportunity to kind of turn RITIS loose on the system there and kind of see what we came up with. And so we kind of focused our exploration on kind of using kind of the probe data analytics suite and also trip analytics. So Sophia is a customer of the trip analytics platform and has traffic data from Hillsborough County. And so we're going to kind of show some kind of fun things that we're able to tease out of both sets of that data for that. So for those folks who don't quite know where, just kind of set the stage there. So, most folks know, you have, here's kind of Central Florida. We have Orlando kind of up here, at the top right. All the tourist and theme parks. We have our beaches down here on the kind of the left side. And then Tampa and the Selman Expressway kind of sits right in the middle where all these interstates, kind of come together. Here's kind of another example of that. You can see how the expressway goes, obviously at the Gandy Bridge over to 75. There's also this very interesting connector that was put in about 10 years ago between I-4 and the Selman, and you're going to see how important that is here in a few minutes. So we see some of those trip patterns. These are the reversible express lanes that go from kind of the Brandon area over to downtown Tampa, and we'll kind of show a little study of those here in a second as well. So Bob, do you mind if I just go ahead and start going through the case studies?
Yeah, and I'd like to, one of the things I'd like to mention too, Charles, was one of the things that Charles and the Cat Lab did so well for us is, as I said, we're a 23-person agency operating, this roadway. I was able to tell him our situation and talk to him about what I was looking for, and then they came back with solutions, which to me, and when you have a limited staff, I have a planning staff of one besides myself, that is very helpful. And being able to do that and being able to use it for a transportation function like we're doing, I can't emphasize enough how much setting the problems and then having a selection of solutions really expedited things. So I just wanted to get that out there, Charles.
Okay, thank you. Okay. So the first thing we did was took a look at, so the first use case was, can we accurately identify, the times and locations of congestion? And so the first thing I did was use the congestion scan tool, which many of you have probably seen here before. So we have down the middle, this is the Selman Expressway. So Gandy Bridge here on the west side is down at the bottom, and 75 is the top with downtown in the middle. And you can kind of see, here's going from midnight to midnight. So this is afternoon over here and morning in the middle here. So you can see we have about 4 main areas of congestion that was picked up by the tool here. So one of them in the AM peak period, this is going westbound, approaching downtown. And then in the afternoon, there were 3 areas that were picked up. So there's also approaching downtown on the westbound side. A couple there, and then there's a very large one here, number 4, approaching downtown, coming up on the east side. Sorry, eastbound from the west side. We can see that on a map by using the trend map, and this is kind of a fast animation here, but I'll slow it down so y'all can see it. So in the morning, you can see around, you kind of click that through to about 8 or 9 o'clock or so. Come back. So there we go. So here's our congestion coming in the morning. And then if we kind of come over here to the afternoon, we can see here's our inbound congestion here on the eastbound side, on the western side of Tampa. And then those other couple blobs here coming in on the other side. And again, those are kind of shown here, kind of to line up the ones that we've seen before.
Charles, could I mention something here too?
Yeah. Mm-hmm.
Just want to. One of the uses that we found for this year was in the development of our work program, showing this information on where it is. This matches almost exactly our current work program of the South Selman capacity number 4. We're looking, the East Selman on number 2. Whiting, we're putting in a new interchange that basically is moving the access to the city of Tampa further to the east, is number 3. And the way the data matched up when I was showing my board and being able to show people really helped them understand where these projects were and the limits were versus why they're there. So I just wanted to, it's real life that happened. This is part of this work program, which will be approved July 1st.
Okay, thank you, Bob.
Sure.
So we can take a look at that using in a different way, using the bottleneck analysis tool. So the trend map and the congestion scan kind of shows where things happen globally, but we can use the bottleneck analysis to kind of filter down and see how things a little more granular on time of day and day of the week. So we can see here, this is the section that Bob was mentioning about that's going to be covered by the South Selman expansion project. We can see how using this spiral graph. So this is midnight at the top, this is noontime at the bottom, and it kind of goes around like a 24-hour clock. And so we can see that between about 2:30 and 7:30 is when we typically see those bottlenecks occurring. And since they're blue, it shows they're between about 2 and 5 miles long. And if you notice the banding in here, so there are little groups of 5 with these little gaps in between. So that tells us that this is weekday congestion. So those little gaps that you see in the middle, those are the weekends. We can see a very similar pattern here on the other side coming in. This is the other, approaching in the morning. This is in the morning, you can see here. So this is between, say, typically between 6:30 a.m. and 10 a.m. Again, these are a little bit longer, and they're also very heavily banded and kind of grouped together to show that this is really, kind of the east, weekday congestion. Using the dashboard tool, which is another PDA tool, we can also look back and see how bottlenecks change over time. And what we're showing here is 1 and 2. We can see that those have been very consistent since September. I ran this in March, and I'm sure if I were to, so there's a couple months of data that aren't shown here, but you can kind of see the trend. That 1 and 2 are very very prominent and very repeatable. So those are definitely ones that are good to zero in on and take a look at. We can also see how congestion changes over time. So these are some other congestion scans that I ran for the month of September through January. You can see fairly stable conditions here on this side, which is where the South Selman expansion is going to be. On the other side approaching, you can see it kind of varies a little bit from month to month. So like October was the worst. September was the best. You can kind of see that smaller blob there, and then kind of fairly consistent otherwise. So we've been talking about South Selman quite a bit. So let's go ahead and kind of zoom in on that project a little bit here.
Charles, can we
Yeah, go ahead, Bob.
on this one here, let's talk about we're able to do this, but for reasons of a procurement, I need to move through this one, please. I have a procurement on the street. These slides, I prefer not to.
Okay, so I'll jump off past that, but so I will mention one thing that came off of the public website that talked about reasons behind the project. Was it kind of mentioned trying to minimize cut-through traffic, coming through neighborhoods and everything. So I wanted to see if we could test that hypothesis, showing that, how, what does that cut-through traffic look like? Is there an incentive to take it, and how can we analyze that? So we have 2 routes here. The green is the Selman Expressway, going from Gandy Boulevard up to downtown, and the purple is Bayshore Boulevard. So this is a local. I don't even know you call it an arterial. It's more of a kind of a local road that comes up here right along the kind of very scenic route that comes up along the bay up to downtown Tampa. So the first thing we did was I took a look at the Selman Expressway speeds. So these are kind of your average speeds for October through January. You can see what the speed range here. It's typically between 55 and 60 miles an hour, except between 2 p.m. and 8 p.m. You can see a big dip in speeds here. Kind of this shaded area is like the speed variability, and then the solid line your average. So you can see a very definite drop here, kind of between 2 and 8 p.m. If we flip this over to travel times, we can see the travel times are typically about 5 minutes long. But then between 2 and 8, they can go up to about 15 to 20 minutes, and then sometimes even 30 to 35 to 40 minutes. Kind of during that period there. So I ran one of these. This is for Selman. I ran another one for Bayshore Boulevard, which is the purple one here. And we can see that most of the time it's much faster to take the Selman because you have 5 minutes versus 10 minutes. But during the middle of kind of that worst period, you can kind of see those backups. There may be an incentive for people to take an alternate route, during that, especially when there's some very, like an incident or very, long backups on the Selman there. So this kind of speaks to the, the need for the project, which Bob was talking about, and which which Thea is going through with. Another way to look at this too, I pulled some performance summaries. So these are just average numbers of travel time between 4 and 7 p.m. on weekdays. And you can see here, I just kind of plotted this like just a delta. So Bayshore minus Selman is your difference in travel time. So it's a positive number, Selman's faster, negative number, Bayshore is faster. So we can see that it's about the same, but when things go bad, Bayshore is actually kind of a less risky option, so which is not what we want to see. So our third use case is, so we know that there is kind of an incentive for people to take that alternate route. So can we tell what percentage of traffic is actually doing that? And so I set up this, this is switching over to our trip analytics tool. So I built this little study area and showed in gray. So I'm just concerned about the Selman, which is kind of this here on the left-hand side, Bayshore, and then kind of the roads in between. So when we run that trip analysis thing there, so I'm showing traffic coming from this intersection here that encompasses Gandy and the Selman there, going to downtown Tampa. So actually getting off and going to someplace in downtown Tampa. We can see for this particular period, this is during the afternoon, about 81% of the traffic was on the Selman, and about 19% of that traffic was actually on Bayshore. So it's a fairly significant.
Charles.
Yeah.
Yeah. Let's move through, please.
Sure thing. Yep. Okay. So our next thing was the use case 4, most popular trip patterns, and what I did was I built a little study area here around the Solomon Expressway, and we can kind of see all of our on and off ramps. So this is kind of, so each little on and off ramp is an origin and destination. So kind of zooming in. So this is kind of what I did. So you can say these are kind of our start and end points. And I put some little zones here along the expressway. So it's basically filtering for people who got on and off at some of these points and had to take the Selman at some point on their trip. So by doing that, we were able to have a clickable map that shows, basically kind of a quick origin destinations of, if somebody gets on it with this particular ramp, what percentage of traffic is going to each destination ramp. So for example, here, getting on at 75, we can see this is the distribution of trips going to other places on the system. And once you set this up, this is kind of very easy to click through and get this information. We were able to use this to kind of determine, at least this is for December, what are some of the top 5 most common trips. And we can see 4 out of the 5 of them that I'm going to show you use this connector between I-4 and the Selman. So it's kind of really picking up on this diagonal traffic that really wants to come down, up and through this way, which, up until about 10 years ago was much harder to do. So we have our traffic going from I-4 down to 75. And then in the afternoon, that return movement, that's number 2. Number 3 in the morning, we have traffic coming from I-4 kind of down into kind of this industrial area of Tampa. So there's probably a lot of trucks doing this movement here. Number 4, we have our traffic coming over in the afternoon from Pinellas County, coming down here from MacDill Air Force Base, heading up to I-4, and kind of heading out to points east. And then number 5, we also have this movement from 75 north, kind of coming up here to 301. This is like another kind of industrial area and kind of a good, alternate arterial for that. All right. Our last use case we're going to take a look at is talks about another recent infrastructure project that Thea deployed there. So, we talked about our reversible express lanes, and those run in one direction in the morning. They kind of split in the middle of the day, and then run the other direction in the afternoon. So you have your regular toll lanes, which they call local lanes, are on the outside, and then you have these little slip ramps that connect the regular lanes to the reversible express lanes at specific locations. And this is kind of what it looks like here. So we have our local lanes here on the outside, and we have our reversible lanes in the middle. So note kind of the white on both sides of the road there. So those are reversible lanes. And we got these slip ramps that go in between them. So if you want to go from one to the other, you just kind of hop on these ramps and you can make that movement there. So Bob, you can talk about this here a little bit if you want to as well. But basically, Thea noticed, kind of wanted to put in some extra slip ramps to like basically pick this traffic up right as soon as they get off here on off of 75 to allow them to hop up on the reversible lanes and then kind of get off just before going into downtown. You can kind of see what those look like here. So I set up a little study area that picks up this traffic just upstream of that slip ramp so I can get people going on the local lanes or taking the slip ramp to the express lane, to the reversible lanes. And then I put another one here just downstream. So anybody getting off the reversible lanes or from the local lanes gets picked up here. So you have to make that whole trip. So this is kind of what it looks like here, going from here all the way to here. And these are the results of that. So you can see 14% of the people, and these, all of this traffic could take the new slip ramps if they wanted to. Only 14% did. And this is getting on as soon as they clear I-75 and getting off at this ramp up here. Those people were the winners. They were able to do that trip in 6 minutes at about 60 miles an hour. About half the people skipped this one and got on at the next slip ramp up here. It cost them 3 minutes. I mean, it took them 9 minutes to make that trip. And the people who didn't take the express lanes at all, about 38%, almost, a third of the people, it took them 11 minutes, almost twice as long as the people taking the reversible lanes with 35 minutes. So this is kind of kind of data that can be used to encourage folks to perhaps like advertise the use of those express lanes and kind of encourage people to make that choice if it makes sense to them. So but definitely kind of different routes can definitely affect your travel time there. So really the big takeaway here is really just to kind of be curious, kind of see where the data takes you. This was kind of a neat exercise where we just were able to just kind of unleash RITIS and just kind of see what we found and go where the data kind of led us there. So Bob, do you have any closing words kind of before we move on to the next?
Yeah, basically been using it mostly on work program and looking at projects to see how they, like the slip ramps, how they actually did they accomplish what they were trying to accomplish. So we found that the RITIS tool is very, very good for that. And at that level of probe data, there's definitely some uses that we're putting that type of thing together. So thank you.
Thank you.
Well, thank you, Charles. Thank you, Bob. Certainly appreciate the really great presentation. I think what we will do, if you have questions, is go ahead and throw those into the Q&A box at the bottom. Our panelists will be monitoring that and can answer those questions during the next presentation, and we'll certainly provide those answers. But with that, Greg Jordan, are we going to switch to you, or Michael, we're going to switch to you?
Actually, I'm going to go first, and then we'll come back to Greg. Sorry about that.
No problem.
So we're going to start off today by talking broadly about some of the new features and capabilities that we're working on in RITIS or have been released or about to be released. The first is one related to trip analytics. So Charles just showed some examples of some trip analytics queries that were used in down in Tampa. We're now updating trip analytics for certain data providers that have access to things like trip purpose, demographics, or for commercial vehicles like the vehicle type and the weight class in the industry. We're trying to incorporate those additional metrics into trip analytics. So for example, here, this is a truck trip analytics query that was run. You've got origins and destinations shown on a map here. And then you have histograms over on the right that show you additional information about all of the trips that are contained within this map. And what you can do is you can interact with these graphics. So you come up here and you put your mouse over this particular vehicle type class, and you can click on it. And when you click on it, it then starts to filter and says, so if you want to know where all the trucks are, then it's going to break down the trucks by weight class and show you what percentage of all the weight classes and all the industries are represented just by trucks as opposed to multi-purpose vehicles, buses, or passenger vehicles. And then being able to double filter. So I may have clicked on trucks, but now I also want to click on this particular zone. And so that then further filters down the data. And you can keep doing that over and over and over again with different selections as desired. So that is being built out right now. We think we're about another month away from having this deployed. The next thing that's making good progress is global data and specifically three-dimensional data. So we are nearly complete building a 3D version of RITIS, which will let you fly around and see data, not just in your neck of the woods, but around the world as well. And that's going to include the normal stuff that you're used to seeing, but if desired, we can also do air traffic and maritime traffic as well. But having this new 3D global capability is something that we're particularly excited about. And because we're starting to process global data and other modes like maritime data and air traffic data, we're also building out a version of trip analytics that will allow you to explore maritime traffic as well. So for those of you who are interested in freight or port related activities, maybe combining trips from land to sea and then back again, or what have you. We're building that capability in, and it'll have the ability to look at trips that go, say, from the East Coast to the West Coast through maybe the Panama Canal, then being able to look at the key routes that are being taken to get from and through those particular locations. So that's in the works. That's probably still got another couple of months to go. But we have just released some new safety data analytics capabilities. So several of you have provided your police crash data sets to us, and those are now available in the event query tool, where you can run all sorts of corridor-based queries or regional-based queries, or even look at individual intersections and look at the types of crashes that are occurring along particular corridors of interest. Look at heat maps. We have these graduated circles, which kind of cluster all of the crashes into regions. We have these corridor diagrams that will show you like how many hot spots you have per every mile of a particular corridor and which particular stretches of roadway are more dangerous than others. But the newest thing that's been deployed is we now have summary reports that you can print out from your police crash data sets, which will just give you statistics about what's going on in the region that you queried. Or you can do statewide maps that will maybe break down your state by county or other jurisdictions and map different type of crash counts per those regions. So all of that has been deployed now at this point. Now, hopefully by the end of this week or perhaps next week, this next feature will be deployed. It's enabling the custom naming of corridors and the travel time dashboards. So for those of you who use these real-time dashboards that give you like the current speeds and the current travel times and how that compares to historic conditions, we automatically name all of these corridors for you based on like the starting and ending point. But a lot of people don't like the names. They're just not appropriate for what the agency wants to call them. So we are now giving you the ability to go in and edit the names of each of these corridors at the time of creation. And then you'll also have the ability to go in and edit them after they've been created, to go in and change the names of the headers and the names in here as well. So that is that is coming very soon, perhaps as early as next week. So be on the lookout for that. And the next thing that is also within a few weeks of deploying is being able to take the congestion scan graphics that you saw earlier. Charles was showing these down in Thea. In addition to just looking at congestion, we're now working to integrate dash cam images from commercial vehicles into the congestion scan. So you can actually see what is on the roadway at any point in time. So you can come down here, you can put your mouse over a particular area and click on it. And these little circles represent images that are being taken. So that's what that vehicle was seeing at that particular part of the roadway at 4:41 p.m. You can move around. You can see all the different vehicles out there. Some of them, you're able to go in and pick up on things like cones out on the roadway or other traffic control devices. Now, this particular query right here, there's nothing terribly exciting happening, but if there's severe weather, you can see the rain. You'd be able to check the snow. Could check to see if your construction zone is active or not. Here's one where it was raining. You can actually go and you can turn on the dash cams. There, I just turned them on. Over here, there's rain that's occurring. If I put my mouse over, you can actually see the road is wet. You can see how much rain is falling down the roadway as well. So that capability is very close to being completed. And then we're also working to build in those dash cams into the real-time RITIS map. So you'll be able to go into the map, you'll be able to click on a segment that you're interested in. Let's say someone is reporting that there's a crash that's out on the roadway. Maybe it's coming in from a Waze user, or maybe it's an unverified report. You don't have a CCTV camera nearby. You don't have a safety search patrol to send out. You can click on the roadway, and then we'll figure out where the trucks were within the last few minutes, and we'll bring up the images, and we'll give you a little timeline slider. You can go back and forth, and you can actually see if there's a legit crash that's out on the roadway or not, so you know whether or not to dispatch someone. This is still probably another 4 or 5 months away from being deployed, but the congestion scans is very close. So those are things that we've been working on that others have funded, but now I want to turn it over to the other Bob Fry from MassDOT, who will talk about the Enhancement Working Group and some of their recent results.
All right, thanks, Michael. So yeah, I think most of you are familiar with our Enhancement Working Group. We maintain a pooled fund to help pay for all these great improvements in RITIS and help the CAT Lab prioritize their projects and focus their resources. Next slide. All right, so our last meeting when we got together in December, we voted on all these various options here that you see. You can see it covers a lot of different areas, dashboards, safety, freight, delay metrics, and different functionality upgrades. And we asked our members to rank their agency's top priorities. So let's see how we voted. So we asked everyone to rank their top 5 priorities. And the top 2 here, the truck parking analysis tool and the automated work zone reporting tool. You'll see much more of that coming up. The third highest priority is the embedding and publishing of dashboards. This is a great feature for reports and presentations. It allows you to take these dashboards with the various performance metrics and save them as different file types, and then you can just drop them into Word or PowerPoint or Excel. The fourth priority is the availability of INRIX XD segments instead of just the TMC segments. in the user delay cost tool in the PDA suite. So since XD segments are shorter than TMCs, you can get more detailed and zero right in on the exact corridor that you're trying to analyze. Next slide. So then this is just the votes of the contributors only. The contributing agencies, my MassDOT for one, also Georgia, Oregon, and Virginia DOTs voted on this as well. And compared to the previous slide, it's good to see that our priorities were consistent with those of the entire group. So bottom line here is if you're a contributing member and your DOT contributes funds to the pooled group, you essentially have a bigger vote. As always, we always need more funding. There's different sources that you can go to, and people should feel free to contact me or Michael if you have any ideas about that or are considering donating. So again, we always need more. And I think with that, we'll turn it back over to Michael to talk about the work zone reporting tool.
Yeah, so the number one voted item is this concept of being able to report on the performance of your work zones, but do it automatically. Don't set me in front of a computer and make me run a series of queries for the next couple of hours and format it myself and put it into a report. But do all of that hard work for me. So we started this work last year. We're still working on it today because it's a big project in and of itself, but we think we're going to be completed with this possibly by the end of this calendar year. We've already done some good work on the speed and delay metrics and their summary panels. We've done a lot of back end work as well to support the computations behind this. But just to remind everyone what this is going to look like when it's completed, you're essentially going to have an interface that will just let you select existing work zones that we know about because you're giving us your work zone data. Or you can go into the Probe Data Suite and define where your work zone is, like the starting and ending points of those places. And then out pops a series of reports automatically for you. The first is just a summary report, which gives you some congestion metrics, some speed metrics, and some delay metrics. And for each of those, you as an agency gets to set what your performance goals are for that work zone. So for example, maybe one of those goals is to ensure that congestion does not, there's not a queue that's longer than 5 miles for more than 20 minutes or something like that. Or you don't want the speeds to drop below a certain metric or go above a certain metric or something like that. You can set all those things in here, and it tells you whether or not you're meeting those performance goals for the week that you selected. And it compares this week to the pre-work zone conditions. The next few slides are other reports that pop out that are deeper dives into each of those metrics. So first we've got the congestion metrics. The congestion metrics, they repeat what your goals are and whether you met your goal. Then it tells you by hour of day and by day of week when the work zone was congested. And down here at the bottom, we've got a diagram. It's essentially a timeline going from left to right, Monday through Friday. The blue zone, that's when the work zone was active. And then the blue lines that go up, that's the length that the queue got to during certain times. We show you when the lanes were blocked. We even show you when there were crashes or weather that occurred during the work zone as well. Then we got the same thing for vehicle hours of delay, where we're showing you the total number of vehicle hours of delay during the work zone and during normal hours. Then we're giving you other metrics. We sum up the user delay cost as well for you. The next one is a table of by hour by hour of day and by day of week, the vehicle hour delay and the use delay cost, just like you'd see in the existing use delay cost tools. And then last but not least, we just lay out a bunch of different metrics for you for the whole week: Monday, Tuesday, Wednesday, Thursday, Friday. Again, the blue zones are when the work zones were active. And we're showing you things like the collective length and duration of congestion, the speed through the work zone, the average travel time and delay, the air temperature, the precipitation rate, and other potential impacts that may have made this work zone worse. So for example, if there were crashes or weather or stuff like that. So giving the ability to automatically produce these reports is what we're building out right now is the #1 ranked item. Now that said, the second most ranked item was being able to go in and do more work related to identifying truck parking availability, truck parking locations, and where there is potentially unsafe truck parking that was occurring. So at this point, I'm going to turn the show over to Greg Jordan, who's going to talk to you about the foundational research that we've been doing to understand whether or not this is available or not with different types of data sets. We're looking at INRIX and Geotab data at the same time. And he's going to tell you what we've found out thus far, and he's going to tell you about some products we're working to build with this enhancement group funding. So Greg, I will turn it over to you, and I can keep sharing if you want, or you can share.
I'm going to go ahead and share. 1 second.
All right, let me stop sharing then.
Entire screen. Share. Go to here. And here. All right. Can you see?
Yes.
We can, yep.
Okay, great. Okay, so Michael kind of led into it and Bob did as well. We're basically looking at, Trip Analytics has this whole ability to take databases of movement of different types of vehicles and information associated with them. Generally speaking, these are real world trips. They have a starting point, they have an end point, and a pathway in between. The degree to which the raw, tight information can be revealed is subject to privacy restrictions, but we're looking at these without regard to privacy restrictions just to see what's in there, and then talking about how we can use tools that protect the privacy of the people supplying the data, but allow us to draw the insights. But these are real world trips. Often there's somewhere around 10+% of the real world trips on the road. You're basically taking location GPS pings and snapping them to the roadway. In the case of trucks, they're almost always connected trucks or telematics, something aboard actual trucks and not cell phones. When you're using other vehicle classes, sometimes we use cell phones. But you have this notion about where it started, where it ended, and then in time-stamped segments along the way. Usually, these are procured or licensed based on a geography that says all trips that touched this geography, you get the entirety, even if it started outside the geography or ended outside the geography, you understand where they came from, where they went to. So what we're going to do here is look at specifically how detailed can we get. And we're going to start with this data set from INRIX. They're now offering basically a truck-only, a freight-only data set that essentially a trip starts when it parks and it ends when the parking event is done. So it's a little backwards, but basically a trip starts when the driver wants to rest and ends when the driver departs. And this is some of the raw data. These endpoints are not blurred for privacy. These are the raw data of where they're actually these events are happening. And one of the quick scans we did was, can we find any concentrations where you wouldn't expect to find them? And this is north of Baltimore on I-83 coming down, up and down toward Pennsylvania. And here's one of the ones that kind of jumped out at us of vehicles that are parking where you wouldn't think they should be. And as a matter of fact, if you look at the zoom in on the left, you can see the oil stains of the fact that this is commonly used. And in fact, I actually drove through this a few weeks ago in the middle of a rainstorm in the middle of the afternoon on a trip down from Pennsylvania, and I saw about 5 or 6 trucks on each side of the road that were using this spot. So this just kind of jumped out at us. You can also go to the rest stops and look at, in this case, it's heavy tractor trailers and where are they parking. And you can look at the medium trucks, which are more box trucks. And we see that a lot of those are going around where the cars go. You don't see tractor trailers going there, but you see cars. So this is the kind of information, and we're going to just kind of dig in and say, what kind of insights can we get from this data? So for example, what if we classify as low risk parking events? And it's not a question of legal or illegal or striped or unstriped. It's a question of what's your exposure to full speed highway traffic. And so if you're parking if you're parking even on a shoulder of a ramp, as long as you're separated, we could call that low risk. It's certainly riskier if you're along the on-ramp or the off-ramp. And the riskiest, of course, is when there's no ramp in between you. You're literally parking along active full-speed traffic. So here's a rest area, a pair of rest areas that we looked at. And I took 1 month, this was October last year, of precise parking location data and said, let's just look at it and see what we can, what's in here. What do we have to work with? And one thing this is a GIS analysis, but basically let's classify them by 4-hour blocks of days. So you've got midnight to 4 in the morning, 4 to 8, 8 to 12, and so on. So you basically have 6 time slices. Let's take all these little kind of pink little dots here and let's overlay it by clicking on one at a time. So if we look at the first period, 12 to 4 in the morning, we've got one of them in this really unsafe, risky area. And then we've got a bunch that are kind of along the off-ramp. These are ones showing up in the middle of the night, and you actually have more of them parking down here than you actually have them here. Keep in mind that for each sample we have, there's probably 9 that we don't have. So what we're trying to do is take the location of where they're parking and use that as a surrogate to kind of infer where safer spots are available. If we come into the 4 to 8 in the morning, again, we have very few vehicles arriving, and for the most part, they're not parking down in this most risky area. Interestingly, from 8 in the morning till noon, that's when we actually had more than we would expect down in this risky area. And then from noon to 4 p.m., we have nobody showing up down here. And then 4 to 8, we're showing 1. So here's just a way to look at it by time slice. We haven't done a study of 10 different sites with ground control. We'd like to do that, but at the moment, this is where we are right now. We can also take those time slices and also put them by day of week groups. So we can have Mondays and Fridays as a group. We can have Saturdays and Sundays and as a group, and we have midweek as a group and look at those separately. And in fact, if we break them down by time slice, we're turning on all hours of the day from Mondays to Friday. And that's, this is what those look like. And we've kind of exploded them out. And then Saturdays and Sundays, we see what we're looking. And then Tuesday, Wednesdays, Thursdays, and kind of the midweek, we actually had very few down in the really risky areas. Usually in a conventional wisdom, we think that those are our busiest days. But this is a part of looking at the real data and seeing what's out there. We can also take them hour at a time and literally go by hour slice and by day group. So there's a whole lot of information in here. And this was kind of the first cut to kind of see what we're getting. Then we said, what could we do with trip analytics? And see how to use the tool. And what we're showing here today is actually what we're showing next is actually already in the tool. You can draw a low risk area. You can draw the kind of the risky off ramp or on ramp shoulder parking. And then the high risk would be upstream or downstream. And by drawing these zones, we can filter for trips that ended anywhere in here and see where they came from and see where they parked. So in the case of this particular, a month of data for heavy vehicles, we found about 180 trips, truck trips that parked in the men, and this is where they were coming from. And these were the counts of where the various trucks are coming from that all ended up parking in that area. And this is where they parked. And we actually have the counts, and we're showing basically 88% of them parked in what is regarded as the preferred place that we want them to park. But we also had a significant number that were parking in risky locations, about 7% upstream and about 6% downstream. So this tool, and then of course, we can break that out by time slice, noon to 3, 3 to 6, and 9 to midnight. All of that is possible today using trip analytics. Now, the other aspect of this that's really interesting are the duration of stay. Not only where are they parking, but who's parking and where do they come from, but also how long did they stay? And so we're actually working on these designs right now, but essentially you have, you get to pick your lot, you get to see a rendition of what it is, and then analyze duration of stay. Less than 1 hour. We've got a percentage here of, basically 59% of during the time slice you pick. So you pick October, you pick day of week, hour of day, you get to filter it down there, and whatever you set there, you get to see the pie chart. You get to see who's staying from 1 to 3 hours and 3 to 7. And here's the ones greater than 11. These are the ones, the long-term rest, the blue and the brown. And then by day of week, we can actually see what those percentages are by group. And by hour of the day, what does that look like, and kind of get that glance at one time. Now, this is a lot by lot view, but you can also, if you have all these different lots, pick combinations of lots or the entire statewide performance of these lots and put the graphics together. And all of this is underpinned by real trips. The degree to which those whether we can provide the individual trip data remains to be seen, but that's all what underpins the whole thing. So that's what I have, and I'll just hold for questions at whatever time it's appropriate to do that. And I'm going to stop sharing right now.
Appreciate that, Greg. I think looks like there's been a few questions that have come in, and I think, certainly it's a question for myself. I think you mentioned, and perhaps I just missed it, Greg, was that there was a conversation about diving into NRIX and Geotab to see whether or not these could play nice within the RITIS tool if it was spitting out the data that we needed to do this truck parking piece. So I guess my question would be, are we seeing a difference between those two vendors so far, or both of them playing nice with the RITIS analytics tools to get this figured out?
I think it's a great question because each of these data sets brings something different to the table. If you want to know demographics about the trucks and the actual movement of the types of freight that are moving, the Geotab database has a huge amount of information that are correlated with their trips. And the more precise movements and precise spots where you end, they both have that there. But they also have different privacy rules. They have different things that they do. So they're two different data sets, and we're digging in to say, okay, when we're done here, we're going to say, this data set is best if you're trying to do this. This data set is best if you're trying this, or they're both bringing the same thing to the table. So I think we're still evaluating the different data sets, but both, everybody's cooperating with us, everybody's helping share the information, working with us. And I think it's kind of a bright day to be able to get a lot of this information.
That's great. Appreciate that. And there was a few questions that popped in. The first one was, what's the rough percentage of truck traffic? Oh, it looks like it already got answered, so never mind. Again, it looks like the rest of the questions, Greg, don't necessarily pertain directly to you, but as folks have questions, feel free to put them in the chat. I think with that being said, Michael, I think that we get to move this into more of our user feedback session, our poll pieces, which I think will also give folks a few more seconds as well to post any questions that they may have as it relates to the presentations they've heard today.
Thanks, Matt, and also thanks, Greg, for your presentation. I know a lot of people have been excited about the truck parking stuff, and also a few people have expressed interest in knowing more about the federal rule requiring states to improve their ability to talk about work zone performance and work zone analytics. And so we developed our dashboards here long before that rule came out, and now we're looking at the rule and seeing what we can do to modify our dashboards to try to meet some or all of those requirements. But we're not done with that effort yet. But some of you have expressed interest in helping us get through that, and so we'll reach out to you and we'll have more discussions about it. But you know, these new features that we discussed today, those are things that you all requested, and the tools only get better when and if you tell us what you don't like and what you wish we did that we don't already do. So now's your time, and you can do that verbally, or we're going to open a poll now that will let you tell us a couple of things. One, are there other topics you'd like to see us present and talk about in the future? Is there anything you're doing that you'd like to talk about in the future? And then next is just detailed feedback on really what you'd like us to do so that we can make the tools better for you. Someone just asked, when do we expect the truck parking tools to be available? I think, well, there's some capabilities that we can offer now to existing trip analytics users using some of the INRIX data, the geotab data, and some of the dashboards that we just showed at the end of Greg's presentation. Those are still several months away from being available. So I would suggest maybe probably in the late fall, we'll have some of those things starting to roll out. That's our best guess on the progress that we're making thus far. You can keep typing your questions, or you can continue to fill out the poll while we wait.
Michael, I have a question. So I saw that there was some interest in doing some integration with INRIX's XD data for the user delay metrics. I guess it's a two-part question. Is that also inclusive of the cause of congestion tool that's out there? So that's first question. And then second question is that only going to be INRIX XD, or is it also going to be here's TS subsegmentation?
So the agencies that voted for that particular topic were INRIX clients. They weren't here or TomTom clients. So we'd probably focus on the XD first. We are a little hesitant to focus on XD and other subsegment types because agencies are still struggling today to provide us with volume data just for the TMC segments. And getting volume data for those subsegments is even more challenging. So we might spend a lot of time building a piece of functionality that then no one can use because they can't get us good volume data. Now, a few agencies are starting to purchase volume data from different suppliers, and that could help, but agencies have to be willing to either produce it themselves or buy it and then give it to us for those tools to make any sense. And I'll use this as my quarterly reminder. I think Bob did it already, but please, please, please work with us to get us your updated volume data the tools work so much better and they're more accurate when we have your updated volume profiles.
Michael, speaking of that, isn't there? I seem to recall a couple of years ago there was a document that was going around that actually shows that process of how you submit volumes to the cat lab. Is that something we can distribute again or share?
Yeah, absolutely. We've got some documentation on the Probe Data Analytics website and help files, but we can forward that around to people. And so that, one approach is developing it yourself. Every agency has to collect volume data anyway for HPMS reporting and other purposes. The hard part, or the harder part, is then conflating that volume to the TMC network. We don't do conflation here. So you've got to do it yourself,
Yep.
or you've got to pay someone to do it for you. Alternatively, you can purchase volume now through the traffic data marketplace from several different vendors. And I guess I'll also use this as a time to plug the fact that the coalition, I believe, just completed another validation effort of the volume data products from different vendors. And Nicole, do you know if that report has been published on the coalition's website yet?
I believe so. I know Zach just talked to us about it, so you can visit the website and check it out there.
Yeah, do that. The vendors are getting better at producing volume data from what they were doing a year or two ago. No one's really doing real-time volume yet, but we don't need real-time volume. We need volume profiles for the roadway. There were a couple more questions. Is access to the NPM-RDS, does it need to be updated periodically? Yes. Well, so the NPM-RDS data set gets updated every week. It's a couple of weeks old when you get it, but it gets updated every week. But to get access to the NPM-RDS data, your agency or company has to have signed a data use agreement, and those only last a couple of years maybe. And so I think what's happening is some agencies are seeing they don't have access anymore. It's because your data use agreement expired and you have to go and you have to sign one again. But there is information on the NPM-RDS website about those data use agreements. And if you're struggling with it, just send us an email to support at ritis.org and we'll help you out. And someone else asked if the slides and the recordings are going to be available for reference. And the answer is yes. Those are posted to the coalition website, or they will be. Usually takes a couple of weeks to get everything up there. Got any closing remarks, Matt or Nicole?
I would certainly say, I think, thank you all for the wonderful feedback and questions that we've gotten to date. I'm sure as we're getting your feedback from those polling questions, Michael and his team, we'll certainly take that to heart. As Michael mentioned, that is very much what populates that list that Bob from MassDOT, has alluded to. It's also something as well that that Michael and his folks go back and look at, to give a tip of the hat to Michael and his team. They're not just looking to this group. They have partnerships all across the country. Work with different government agencies, and that's certainly, again, right, what helps make all these tools possible that we all get to use. So, again, thank you for that feedback. Thank you for your participation in our meeting today. and the great questions that we got. Nicole, I'll go ahead and say that I'm done, and I'll hand it to you for any parting thoughts.
Yes, thank you, Matt. I echo everything you said. Again, thank you for coming. And I believe on the last slide, we do have some ways to contact us. If you have any questions at all, please feel free to reach out and email us, and we will take care of whatever your questions or concerns are. So yeah, the poll is still open, and but we are finished here. So again, thank you.
Thank you all.